Hello everyone, how are you? Today we're completing, this is part 2. Okay, we are solving paper 2 extended May-June 2025 variant 22. In the first part we finished from question 1 until question 10. So today we are going to complete from 11 until 20. Okay, if you have any question regarding the first part, please make sure to ask under the video. So here we are starting with question 11. It says a stationary smoke particle is hit by a fast-moving nitrogen molecule. Which row describes the motion of the smoke particle and of the nitrogen molecule? Okay, I hope you remember this. It's called Brownian motion. Remember, Brownian motion is the random zigzag motion of fluid particles. Okay, so if I have like smoke particles here moving, okay, in air or maybe in nitrogen, and there's like a nitrogen particle come here, the nitrogen particle will hit the smoke particle. So the smoke particle will start moving in a certain direction. Okay, and the nitrogen, this nitrogen will bounce back. Okay, so here they're asking me about the smoke particle. Of course, is going to move. Okay, and the nitrogen's molecule is going to rebound. Okay, so the answer is A. I hope it's clear. Now, question 12 says, bubble of gas rises from the bottom of a lake to the top. The table shows the reading of gas pressure inside the bubble and the volume of the bubble. So pressure and volume of the bubble as it goes up. Okay, the temperature of water is constant. Here they say the values in 3 rows of the table are correct and 1 is not correct. Which row is not correct? Okay, let's remember, when the bubble goes from the bottom of the lake to the top, okay, there will be less pressure. It means its volume will increase. We have to remember something, that pressure multiple volume, okay, is a constant value. It doesn't change. Okay, so I have to check here which option of these will be like a constant PV value. So here I have to multiply the pressure multiple volume. Okay, they should be the same. Okay, so here 360 multiple 2.4, I will get 864. This is in A. Now 270 multiple 3.2, I will get also 864. Now in C, if I multiply 160 multiple 4.6 is going to be 736. Okay, so obviously C is wrong, but let's make sure with D. Multiply 120 multiple 7.2, you will get 864. So the odd one is this. Okay, as we agreed, pressure multiple volume should be a constant number. So it is constant in A, B, and D, but C is not constant. Okay, and they are asking about the one that is not correct. Okay, I hope it's clear. Question 13 says, the diagram shows a glass flask sealed with a small volume of mercury in a glass tube. This is the mercury here. Okay, when the flask is gently warmed, we increase the temperature, the mercury rises up in the tube. Okay, so here we warm it a little bit with a small heat. Okay, so the question is, what is the main reason or the main cause of the movement of the mercury? In A, they say expansion of air in the flask, or B, expansion of the glass flask, or expansion of glass tube, or expansion of the mercury. Actually, when we heat here, the air inside will increase in volume. It will expand, okay, because the distance between particles will increase. They gain more energy. So the air will expand. So it is A, expansion of air inside. Now question 14, it says the diagram shows equipment used in an experiment to determine the specific heat capacity of a metal. Okay? In the experiment, a heater is switched on for a t second, for a time in seconds, and increases the temperature by delta theta of block of metal. Okay, and it is measured in Celsius degree. What do they want? They want which equation gives the specific heat capacity of the metal. Okay, let me remind you, we know already that the heat energy equals to mass multiple specific heat capacity multiple change of temperature. Okay, sorry, here change of temperature they use theta, my bad, theta. Okay, so I need the C here. C equals energy over m delta theta. Okay, I notice in the 4 options I don't have the energy E. Okay, so I remember from before, I know that in general power equals to energy over time, which means energy equal power multiple time. Okay, so I take this and I substitute it in here. I will get specific heat capacity is power multiple time over mass multiple change of temperature. Which option is that? This is option C, this one. So it's going to be power multiple time over m delta theta. This is not option C, sorry, my bad. This is the C, it's option B. I circled B, but I said C. Anyway, so it's option B, okay? Now let's go to question 5. Still we're talking about thermal energy. So the question says the diagram shows 4 rods. Each rod is made of a different metal. I have copper, iron, brass, and silver. Okay? Wax is used to attach small metal balls at the rod ends at P, Q, R, and S. Each rod has the same size. They are heated uniformly by a Bunsen burner. Okay? As the rods warm up, the wax melts and the balls fall off. The question is, why does the ball of the silver rod falls first? In the silver, the ball that is here will fall first. Okay? Of course, we know the heat, okay, starts here in X and it will transfer through each rod. Right? Since in silver it falls first, it means it transfers faster in silver, which means silver is the best conductor. This is option A. Silver is the best conductor. Of course, this is wrong. I cannot say it's the worst. And here in C, they say silver is the best radiator. Actually, in metals, we know conduction. So metals are conductors, right? So it's option A. Okay? Good. So question 16, it says 3 solid copper spheres X, Y, and Z are heated to the same temperature. So notice I have X with the diameter 2D, it's black. Y, it's diameter D and white. Z is 2D and white. The question is, which row gives the order for the rate of emission of radiation. Emission of radiation, since here they're asking about highest rate. Since I have a black is the best emitter. Pay attention, this is not reflector, they're talking about emitter. So black is the best emitter. So X is the fastest or the highest of emission, X. So we are in option A or B. C is wrong and D is wrong. Again, why is that? Because X is black and black is the best emitter, because they're asking about emission, right? Right. Now, I have Y and Z, both of them white, but pay attention, Y has a diameter D, Z has a diameter 2D. So Z is bigger, which means it will emit more, which means that Z is the second highest rate of emission, okay? So we are in option B. Okay, so here we know that the color affects the rate of emission and the size affects the rate of emission. Here, now, this question is about diffraction of waves. Here it says, which wave will diffract the most when passing through a gap that is 0.85 meter wide? Okay, in this case, in order to check which one will diffract the most, okay, we need to find wavelength, right, and compare it to the size of the gap. Here, of course, I know wavelength equal to speed over frequency, so I have to apply this formula in each one. Let's find it for each of them. Okay, in A, if you divide 300 divided 280, you will get 1.07. Here, if you divide V over lambda, you will get 0.75. Okay. Now the third one, if I divide 350 over 280, we'll get 1.25, and the last one, if I divide, I will find 0.875. Okay, please, here I want you to pay attention to the question. The question says which one diffracts the most. Here when they say the most, it means which one will diffract for a long distance. Okay, in this case we take the one with the largest or highest wavelength, so it's option C. So always go here to the largest wavelength or the maximum wavelength. Of course, wavelength you can draw it like this or like this, the same idea. Some students will say, Mr., but we know the best diffraction will happen when the wavelength is close to the gap size, which will be D, which is closer to this number. This will be correct if the question is asking which one gives the perfect diffraction. What do we mean perfect diffraction or best diffraction? In this case, we mean that we can see it clearer. Okay, so when the gap size is equal to the wavelength, we can see the diffraction clearer. Okay. Now we complete to question 18. I hope it's clear. So, which row of the graph shows the amplitude of the wave? I hope you know. The amplitude is B. One of my students is answering. Thank you. Now, question 19. Which row describes a seismic S wave? A seismic S wave. Okay, remember we have S wave and P wave, right? So, S wave is a transverse wave. S wave is transverse, so we are in option C or D. Okay, And transverse wave, we know it, yani the direction of wave is perpendicular to the vibration of particles, so we are in option D. I hope it's clear. Directly to question 20. The image of an object is formed by a plane mirror. Okay, which row gives the correct property of an image? Let's remember, in a plane mirror, okay, it's a virtual image. What does that mean? It means I cannot use a mirror to reflect my image on a wall. So definitely it's virtual, either C or D. So A and B are wrong. And we all know it will be at the same distance, right? So it is option D, okay? I hope it's clear. This is the second part of this paper. Next part we'll do from question 21 till 30 and then from 31 till 40. If you have any question, please leave it under the video. Have a nice day. Bye bye.